Welcome everyone. My name is Mariana. I work as a marketing specialist for the POVAL resin division at Kuraray, and today we would like to have a deep dive on the use of our product, Kuraray POVAL, in the agriculture area, so more specifically for seed coating and encrusting. And before we start with the session, I would like to give you a brief overview on our webinar etiquette. And the first point is this webinar is being recorded. However, your contact details won't be displayed during the session to other participants. And the same applies to the questions. They will be only available to the presenters, so feel free to ask your questions. And for this, also please use the Q&A function. We don't have the chat function available, but the Q&A function you can find at the top of your screen. And we'll have a moment to reply the questions at the end of the webinar. So in addition, the expected duration of this webinar is around 30 minutes, also including the questions. It might vary a bit, but expected duration 30 minutes, and sound and visual features are deactivated as well. And last but not least, this presentation will be shared with you later via email, and the recording will be available at our website under the web seminars page. So going to the next slide. In this webinar, I'm the moderator, so you can see my name here and my contact details. So if you need anything related to marketing or communication topics, feel free to reach out to me. And I would also like to introduce my colleagues who will be presenters for this session. So we have here Joris Bohet, our Market Development Manager, and Shayla Soravia, our Technical Service and Development Chemist. And now I would like to pass to my colleague Joris Bohet, who will explain more about the Kuraray company and our Kuraray POVAL product and our portfolio. So.
Thank you, Mariana, for the introduction and also a warm welcome from my side. So, as Mariana said, my name is Joris Bohets, work as a Market Development Manager at Kuraray. And before we take a deep dive into seed coating and encrustment more in detail, I'd like to give you a quick overview about the company Kuraray, about our product, and how we try to challenge and face some challenges in the market like microplastics. So Kuraray, what is Kuraray? As you can see on the picture, it's a combination of two words. It's Kurashiki, Kura, and that's the birthplace of the company, Kurashiki, small town in Japan, and as well the Japanese name of warehouse. Then we have the product. The first product made by Kuraray was rayon, and there we have the short ray. So together, Kuraray. You also see in the back that next year we will celebrate our 100 years anniversary. So, and I think this shows and this proves our, long-term commitment and our being a reliable and trustable partner for now and the future. On the next slide, we have a little bit of corporate overview. So these are the numbers and some facts and figures. But what I always emphasize here is the R&D expenditure. So 3% of our net sales goes right away into R&D. And this is, let's say, for a mid-sized to bigger company as we are in the meantime, I think close to 12,000 employees. This is really a decent and a significant amount we spent on R&D. On the next slide, we are showing our global network of PVA, polyvinyl alcohol, which is the product and with the brand name Kuraray POVAL. And as you can see, we have offices with the yellow dots spread all over the world, but as well, we have technical centers with the gray dots. But most important, the black dots are the production. So we have 2 plants in Japan, Okayama, Niigata, 1 in Singapore, 1 in Germany, and 2 in US. This makes us with a total capacity of 361,000 metric tons on a yearly basis. So as we are a company who cares about the environment. We want to be innovative, but always hand in hand with the sustainability. So sustainability, we have our sustainability goals, and we also try to act and action accordingly. So CO2 footprint is important for us. We have the LCA results from our factory in Frankfurt, and we are participating in many organizations, like you can see here, like Forever Green, for example. So we as a Kuraray company, we aim to have an honest and open approach about sustainability. We are also sharing our data, and we can share more in detail our visions and actions on request, or you can find everything on our website. Moving to the next slide. Then we talk more about PVOH, polyvinyl alcohol. PVA, they say, sometimes they say more in Asia, actually. So what is PVOH? So on the next slide, you see how we make it. So we make it in 2 steps. So in the first step is this so-called polymerization step. So we change from VAM, vinyl acetate monomer, to polyvinyl acetate. So as you can see in the first step, we actually define the molecular weight. So basically the length of the chain. So whether you have a small chain or a long chain, so this comes with certain properties like lower viscosity. Yeah, this is maybe something to emphasize. So in the world of polyvinyl alcohol, we don't talk often about molecular weight. We talk more about viscosity. Later in the nomenclature slides, you will see. So we measure the viscosity, and then it's showing our nomenclature. So molecular weight change to viscosity. So lower viscosity, so means increasing solubility, increasing drying speed, higher. So a longer chain, increasing viscosity is higher strength and elasticity. In the next phase, then we hydrolyze. So this polyvinyl acetate, we make it into polyvinyl alcohol. So what we do here, so we change the acetate groups with OH group. So, and this defines them. So depending on the percentage of how many acetate groups are changed into OH groups, this we call so the degree of hydrolyzation. Again, we can play with this. So we have lower and higher. So lower starting at from 70% up to higher to 99. So so-called super hydrolyzed. Again, comes with certain properties like increasing surface activity, water solubility tends to be more hydrophobic on the lower side, and the higher water fastness, increasing gelling tendency and more hydrophilic. So that moves, let's say, on to our nomenclature, as I already shared earlier on the next slide. So here we talk, so let's say most of our grades are very open and clear to understand. So we took an example of the Kuraray POVAL, and Kuraray POVAL is our brand name of our polyvinyl alcohol, and the 688. So the 6 stands for the viscosity measured at a 4% solution, in this case 6 MPa. So this is also referring to the molecular weight. And the second part is the degree of hydrolyzation, 88. So in this case, 88% of the acetate groups are changed into OH groups. So this makes Kuraray POVAL 688, just to give an example. So that was a brief introduction about the product. Now we go to the properties, and you see here below, you see the typical applications: paper, textile, emulsion adhesives, ceramics, PVC, etc. So in these are, let's say, historical applications. So we know quite well about PVOH, how it works, how it acts. And we want to use this knowledge now to go further and to innovate into the world of agriculture, and more in particular in seed coating, starting with encrustments. So looking at the properties, so what we believe which are important for seed coating is the water solubility, viscosity controlling, film forming, high strength, a little bit of water absorption, sometimes even more moisture retention, and the good adhesion to cellulosic and inorganic materials. On the next slide, we talk a little bit about microplastics. As we all know, in the world of seed coating, microplastics is a big topic. And on the next slide, you will see what is actually a microplastic. So in October 2023, it was finally decided by the European Commission. So what is a microplastic? So everything equal or less than 5 millimeter is a microplastic. So sometimes you have a combination of non-microplastic with microplastic, but this will always be a microplastic. And the last part, this is maybe most valid for the seed coating world. So sometimes non-microplastics can become microplastics. And what we mean with that is that some products are sold as being microplastic free, which is true, but once applied on the seed and dry out, they will become a microplastic. So that sometimes gives a little bit of confusion, but this is how things are going right now. So how do we position as a Kuraray POVAL? So we have a microplastic statement where we explain in detail, where we also have a list of grades which are excluded from the regulation. And how are we excluded? So we take the solubility criteria. So meaning if you have there is a loading of 10 grams a liter, and if you have a greater solubility, steered and at room temperature, if you have a greater solubility as 2 grams a liter, then you can be excluded from the regulation. And that's what you can find back more in detail in this statement. As well, on our website, we have a small video on how we position with the microplastics. So coming back to PVOH, so why can we use PVOH as a binder, as a sticker into seed coating, encrustment more in detail today? So of course we have the water solubility. We are inherently biodegradable, so that means we first need to come into solution and then we will biodegrade. We are inert, so meaning we will not interfere with any active, non-active ingredients which are added to the formulations. And of course, our value proposition versus other is that we are excluded from the microplastic regulation with our Kuraray POVAL agriculture portfolio. So meaning we are microplastic free. So by that, that was, call it a $5 tour of the company, of the product, and our, let's say, more sustainability part. So, and now I'd like to give the word to Shayla, who did most of the lab tests and coordinated outside testing, and she will give an update. So thank you, and Shayla, floor is yours.
Thank you, Joris. So hello from my side and welcome. Today I will talk about the technical aspects of the PVOH for this application, and I will try to give you an overview of how to use our product, at which concentration, and kind of give you a simple guideline on that. So on the next slide, you can see some examples of the seeds that can be encrusted using Kuraray POVAL as a binder. So typically it would be a grass seed. So there are all kinds of grass seed on this picture. Specifically, I think it's Festuca rubra. Then we have alfalfa, which is very small and round seeds, so different shape of the seeds. And also some very small seeds like carrots and onion can be encrusted using PVH as a binder as well. So typically the reasons for encrusting are to improve size and shape and to add a little bit of weight to the seeds because they are small and very light, but also to protect the seeds from external factors like humidity or some pathogens and so on, and also to maybe improve the visibility. So for our internal study, we used a very simple coding method, which is also typical for the industrial production. So you can see on the next slide what is the coding equipment that we used for producing the data that we have. So it's a laboratory coater, Hopman. It's a rotary coater. So you have a spinning disc inside where the seeds are rotating in one direction. And in the middle, there is a small blue disc where the liquid is loaded onto. So it's dispersed kind of evenly on the seeds. And also there was a filling hole for the powder material. So typically the filler material and the binder as a liquid is loaded simultaneously to the seed. So there is a kind of encrusting buildup during the process. So our equipment is very small. So the batch size for these tests were rather low. It was 100 grams, and we used also the same amount of the filler material. So the buildup was 100%. So the ratio of the materials was 1:1. We used as a filler material pure calcium carbonate. We are aware that this might not be very realistic because typically the filler material contains some other minerals or clays and maybe even some type of protectives for the seeds like microbials or other protective ingredients. But for the simplicity reasons and for the for the comparison, we use the pure calcium carbonate. And as a binder, we use the pure PVOH solution, Kuraray POVAL solution. So that was the setup of the experiments. And on the next slide, I would like to introduce you some of the properties that have the biggest influence on the dusting. So dusting is very important parameter when it comes to seed coating quality. So what are these parameters from the binder that can influence the dusting? So first of all, we have molecular weight. So here, for that reason, we compared 3 different grades which have same DH, so same degree of hydrolysis, but different viscosities. So that means different molecular weight. So you can see in the graph, there is grade 588 or 688, then 1388, which is a mid-viscosity grade, and 2288, which is a little bit higher in the molecular weight. So you can see the dusting kind of declines going from low molecular weight grade to higher molecular weight grade. You can say that this behavior is kind of intuitive because the longer the chain, of course, you have more entanglement and you have more binding power, which is true. We also see that behavior in many other applications. However, for the encrusting, the balance between viscosity or the molecular weight and concentration is very important. Typically, when you have high viscosity grades, they tend to increase the viscosity a lot at higher concentrations. So sometimes if the viscosity is too high, you can have agglomerations. So that looks something like the picture on the left with the red cross. And this is something that you probably want to avoid. So ideally, your seeds would look like very like the picture on the right side with the green arrows. So very singulated, the coating is smooth and nice. So the dusting is very good. So very low in that regard. So that is the kind of comparison between the high and low molecular weight grades. So the second parameter that we found that it has an influence on dusting is the degree of hydrolysis. And for that, we compared these three grades, which have similar viscosity or the same viscosity, but different degrees of hydrolysis. And you can see that the dusting is being reduced when you go from like the degree of hydrolysis is 88 to 82, and then finally the dusting is the lowest with the 574. So 74 is the lowest degree of hydrolysis, and there we had a very low dusting. So the reasoning for that is that we repeatedly saw that with the grades with the standard degree of hydrolysis of 88%, sometimes we had a little bit of agglomeration, and this is pointed out with the red circle in the picture below. So these grades kind of tend to agglomerate a little bit more, not too much, but agglomeration is still present, while with the grades with the lower DH, we didn't saw this. So we see most of the time, always, the coating is very nice and smooth, and there was no agglomeration. So the coating quality overall was very good with the 574 and 582, and therefore we had a lower dusting for these grades. So yeah, also there is a table that we put up as a kind of an overview of the products that we recommend for this application based on our findings. And these are grades, kind of a two groups, lower and higher molecular weight grades. So first three lower molecular weight grades that can be used for this application are 574, then you have 582 and 383, and higher molecular weight grades would be 1388, 1888, and 2288. So if you remember, we talked about there is kind of a balance between molecular weight and the concentration. So based on our findings now, we can tell you what is the ideal concentration that these products should be used at when you're doing the process of the encrusting. So you can use, basically, you can see from the table that for lower viscosity grades, you can use higher concentration without having agglomeration, and the concentration should be lower for the mid or higher viscosity grades. And of course, we have found that the polymer ratio on powder should be somewhere between 2 to 4% solid on solid content, so that you have enough binding power for your filler material. So this is an overview, and you can find more or this overview also as a part of the technical brochure. And with that, I am finished with the technical part, so I will give over to Mariana. Thank you.
Yes, so thank you very much, Shayla, for giving this overview on the technical aspects. And now I would like to, to share more about our support materials. So if you are interested to explore more about Kuraray POVAL for agriculture, so seed encrusting, get more information on the topic, you can find many brochures available on our website. And yes, also interesting videos. So we prepared a folder for you, and you can have access to this folder by scanning this QR code, or later when receiving the presentation via email by clicking on the links available. So one of the videos is our corporate video, where we have an overview of our products, so the applications as well. And the other one is on PVOH and microplastics. So feel free to explore these materials available. And with that, we will proceed then for the questions. So as I mentioned in the chat, feel free to include your questions in the Q&A. Your questions are private and will only be visible to us, so to the presenters. And I will now start with one of the questions that I already see here in the chat. And it is, are you producing in Asia? So this is one of the questions available here in the chat. So my colleague Joris can support with the reply on it.
Yes, so I can reply on that one. So as we were showing earlier, so we have a global supply, and in Asia, so we have 2 plants in Japan, Okayama, Niigata, and one in Singapore. And so yes, we do have production in Asia, and especially in Japan and Singapore. Yeah. Yeah.
Yes, so thank you, Joris. We have another question here, and I think you can already get this one as well. So are we only interested on encrustment? So this is another question. We have it here.
Yeah, I can take that as well. So we started with seed coating encrustment, actually for the reason that we have already commercial business there, and we want to learn and explore from there. So there we that's the reason why we started with that one. So on as a second project, we will focus more on film coating, and corn and soybean, let's say, are the highest priorities there. But let's say we realized that seed coating as such doesn't mean so much. So we learned that making one size fit all does not fit at all. So we have to be, we are very humble in our approach, and we try to help together with our customers to develop new seed coatings, new formulations, hand in hand, because each coater has their own ingredients, own machinery, and we learned that making one guide formulation doesn't work.
So thank you, Joris. We have another question here. What is the solid content of the solutions using in the coating? Example of the seeds. So
Yes.
Sheila could support us with that.
Thank you for the question. It's a good one. So we actually tested range of concentration between 3 and 10%, and for the data that we show today, it was shown for the 5% solution, which was used on the powder material. So it was 5% in this case.
Yes, thank you, Sheila. Another question here. So there are other microplastic binder. What make you unique? So this is one of the questions too.
Yeah. Yes, there are also a lot of other binders which are not microplastic. You have bio-based materials, but also some of the others. And I think unique what makes us, we are a worldwide company, so we have production sites all over the world. So the supplier chain is very good. Then the second point is, obviously the regulatory situation, which is kind of coming from Europe, but also it's across all regions, I think, because seeds are shipped all over the world. And also lastly, since it's a synthetic polymer, the production process is always the same. So that means also that the specification of the product and the quality of the product is also always the same. And I think this is also something important that you can count on when you are doing production process, so that you can always count on the same quality. So there is no fluctuation.
Yeah. And can I also add there, because I saw another question coming in about microplastics. So mentioning, it says, the question is, you mentioned that polymer can be non-microplastic, but can become a microplastic after being applied. So, and the question is here, what about PVOH? Is it also microplastic? So it's clearly our agriculture portfolio for is microplastic free. So we take there the route of the solubility. And if according to the regulation, there are some ways to be excluded from the regulation, so basically being microplastic free, and we take the solubility route. So there is a 10 grams a liter is loaded at room temperature and then steered for 24 hours. And then if you have a greater solubility of 2 grams a liter, you are excluded from the regulation, so basically microplastic free. And all the grades we are offering for agriculture application and seed coating in particular are excluded from the microplastic regulation, so are microplastic free.
Thank you, Joris. Another question in the chat, do you have any technical data sheets available to share? Yes, we do. So on our website, so Kuraray POVAL, we have a tab called Library, and there you can find our technical data sheets for different regions, so Europe, Asia, US. So there you can also find certifications and regulatory information or the relevant documents that you might be interested to check. So yes, the reply is that we do have technical data sheets available. So checking here on the chat, we have one more question. Do you want to become a seed tech company?
Yeah, I can take that as well. So the clear answer is here, no. We don't want to become the next formulator. So we are a raw material excluded from the microplastic regulation. So we are a binder, a sticker, who is just an ingredient for the end formulation of the end recipe. So as said earlier, we are actively supporting our customers with our T&D labs spread all over the world. We have coaters in Germany. We have one in Singapore and soon one in Japan. And we are committed to help our customers based on our knowledge about PVOH and based on your knowledge about seed coating, and together we can formulate and make the perfect recipe.
Great, thank you, Joris. I know we are a little bit above of the time, but we have many questions here. There's one more. Was any correlation observed between germination, behavior of the treated seeds, and the product properties with a focus on molecular weight or degree of hydrolysis? So I think
Yes.
Sheila could support with that one.
Yes, I can take this question. Thank you. So germination testing was part of our external studies because we are not able to do that ourselves. And we actually found that we didn't saw any significant difference in the germination between treated and not treated seeds with PVOH. And therefore, in some cases, it was a little bit higher, but it was not significant difference. So in that case, we can conclude from the study that there was no negative impact of germination, so it was more or less the same.
Thank you. And one more question here. The grades you mentioned are new for us. Are they special produced for seed coating? This is one of the questions we have here as well.
Yeah, I can take that as well. So traditionally, many standard grades are used in regards to polyvinyl alcohol in seed coating and mainly in encrustment. So it's somehow we feel there was not really let's say an in-depth study done of what is the value of using other grades into seed coating, and this is actually what we checked, and we found some superior qualities and properties with some grades, and that's something which we like to explore, and together with our customers, like seed companies or seed formulators.
Yes. So thank you, Joris. Let me just here update the Q&A section. Check, but we are now already over the time, and yes, we still have some questions available. So we would like to take the time later to individually reach out to you and reply to your questions. And with these, so we finish the webinar for today. Thank you very much for your participation. And again, please find our contacts here and get in touch in case you need any further information or technical or commercial requests. So if you have, then feel free to reach out to us. And yes, thank you for your participation. And we would like to close